Greetings of the day, dear students. Today in this video we are going to discuss about the uh, peak value, instantaneous value, average value, and RMS or effective value for a given sinusoidal waveform. In these videos, in a detailed step-by-step manner, we will see how to find out the peak value and also observe peak-to-peak value and instantaneous value, and how to find out the average value for both symmetrical waveform and also the average value of an unsymmetrical waveform in the second case, and later we will discuss the RMS or effective value, right? All these terminologies and the definitions are important, and if you are having 2 mark questions or for internal exam also, a clear-cut idea on this will help you to get more marks. Will help you to get the more marks, right? And you should be very much clear, right? Now, if you observe this given sinusoidal waveform, for the given sinusoidal waveform, as we have already discussed, its mathematical form will be V of t equals to Vm sine of omega t plus phi. This is the mathematical form of a sinusoidal, right? From this mathematical form, the peak value, it represents the maximum value which is attained by the alternating quantity. The maximum value it reaches, that is to be called as peak value. For example, in this given mathematical form, sinusoidal, V of t equals to 311.2 sine of omega t. This Vm represents the peak value. The maximum value occurs for a sinusoidal waveform. Where we will get the maximum value? You know the basics. Sine of 0 is 0. But what about sine 90 degrees or pi by 2? Sine 90 equal to 1. And negative 180 degrees is again 0. Sine of 180 degrees is again pi is again 0, right? Like this we will get a maximum value at omega t equal to 90 degrees. Now its value is 311.2 for this given waveform. That simply indicates the peak value, very clear. So if you are asked, peak value means the maximum value attained by the alternating quantity is called the peak value. Now peak to peak value. Peak to peak value means the positive peak is at plus 311.2. This is positive value, and the negative peak is attained at minus 311.2. So peak to peak represents 2 times the Vm. For given sinusoidal, the peak to peak value is 2 Vm. Based on that, for this given waveform, 2 times 311.2. So the peak to peak value is 622.4. Very clear. 2 times Vm. Right? Next one is the instantaneous value. At some particular instant of time, at some particular point, if we want the magnitude, then that value represents is at particular instant. For example, in the given mathematical form, V of t equals to 311.2 sine of omega t. If I want the value at 30 degrees, exactly at 30 degrees, simply substitute omega t equal to 30. Now we will get its magnitude at 30 degrees. That represents the instantaneous value. Otherwise, if you want its value at 60 degrees at some particular instant, then that value represents the instantaneous value. Clear? At 60 degrees, its value will be how much? 311.2 into sine of 60. So 269.5. So that is the instantaneous value. Now what about the average value? You have to take the integral of the entire waveform. For example, for anything the average value is asked. If you are having a sinusoidal like this, if I want its average value or some other, you take the integral of that waveform and you find its integral over the entire time period, and that value you divide with the capital T, then we will get the average value. This is very important equation. V average equal to 1 by t integral 0 to t V of t dt. Now in the place of V of t, we have to write the mathematical form. Most of the times for our problems it will be sinusoidal. In the place of v of t, what we can write? In the place of v of t, Vm sine of omega t we will write. That is important. Clear? Yeah. Now if it is here, we will come across two cases. Average value, we will come across two cases. One is for a symmetrical waveform and the another one is for a unsymmetrical waveform. Dear students, observe, if I ask for a full sine wave, its average value will be 0. Why? Because the positive area is equal to the negative area. So it's over one cycle, its value is 0. The average value over one cycle is 0. This is because the positive half cycle area is exactly equal to the negative half cycle area. Because of that, the net area is equal to 0. Because of this, what we will do is, in case of symmetrical waveform, very important, in case of symmetrical waveform, instead of doing the integral over entire time period, we will do that integral only for integral 0 to t by 2. Only for half of the wave we will do. And we will divide that value with half of the time period, 1 divided by t by 2. This point is very important for symmetrical waveform. Clear? Now we know that the time period capital T, omega t, we are considering only half of the time period, omega t by 2, 1 by t by 2, 1 by capital T is omega t divided by 2. So here we will get integral 0 to pi. The limits are 311.2 is a constant. We have taken it outside. Simply integral of sine at, integral of sine at or sine omega t with respect to d omega t we are doing. So it is simply cos minus cos omega t. The limits are 0 to pi. That is what we have done here. Very important. The limits are 0 to pi. But what about upper limit? Cos 180 degrees, cos pi is 180 degrees. We will get minus 1. But what about cos 0 degrees? Cos 0 is 1. That is what we will do here. Bracket of minus 1. And again we will get minus of minus 1. So that value is 2. So this is the average value, 198.027. If you express in terms of Vm, its value is 2 times Vm by pi. 2 times Vm by pi. Very important, dear students. The average value for sinusoidal is 2 Vm by pi. Clear? If it is a symmetrical waveform. If you take the average value for full cycle, its value will be 0. The reason is the positive area is equal to the negative half cycle area. Right? Yeah. Now, if the average value of an unsymmetrical waveform, we will do this one for the entire time period. The time period for this waveform is, you have to observe at from what point of time we are getting the same waveform. Up to there we have to consider that as the time period. For this given waveform, the capital T is 2 pi. But in order to find out the average value, what is the formula? This formula is very important, dear students. V average equal to 1 by t integral 0 to t V of t dt. Clear? In the place of V of t, the mathematical form is simple. You have to remember this one. V of t is what? V of t equals to Vm sine of omega t. That is what we have done here. If you observe, even though you have taken the limit is from within the limits 0 to 2 pi, split it into two parts. This entire integral, which is within the limits 0 to 2 pi, let me express in two parts. One is within the limits 0 to pi plus the other one is within the limits pi to 2 pi. But if you observe from pi to 2 pi, its magnitude is 0. Pi to 2 pi, its magnitude is 0. So this value will be 0. Within the limits pi to 2 pi, its value is 0. This step is very important, dear students. This is where most of the students will commit the mistake. You have to take within the limits 0 to 2 pi But if you split it into two parts, 0 to pi plus pi to 2 pi, if you observe from pi to 2 pi there is no magnitude, its value will be simply 0. Now integral of sine omega t, integral of sine is minus cos, that is what we have done here, and we have applied the limits 0 to pi. Cos of pi minus 1, upper limit minus lower limit, minus of cos 0, upper limit minus lower limit, right? We are getting here 311.2 whole divided by 2 pi into 2, it is 99.013. So if you observe, if you express in terms of Vm, peak value, it is simply Vm by pi, average value for unsymmetrical waveform, Vm by pi. Clear? So that is what all about the dear students, instantaneous value, average value, and peak value, and peak to peak value for a given sinusoidal. And next we will discuss about the RMS or effective value. Okay.